Dear students, today continuity of RD Sharma class 12 exercise 9.2 remaining questions we will solve. So question number 15, show that f of x is equal to modulus of cos x is a continuous function. This function we have to prove continuous. So f of x is equal to modulus of cos x. For proving the function continuous, we require point, and whenever the modulus function is given, so we can get the point from inside the modulus function. Just substitute the value inside the modulus function is equal to 0. So cos x is equal to 0. If we put cos x is equal to 0, then solve this for the value of x. Cos x is equal to 0. So one particular point we can take cos pi by 2. Cos pi by 2 is equal to 0. So from here we can get 1 point. So on comparing x is equal to pi by 2. Any other points also we can take for many values of this cos x is equal to 0. If cos x is equal to 0, then 2n plus 1 into pi by 2 is the value of x. So here we have taken 1 point cos pi by 2. Cos compared x is equal to pi by 2. So at this point x is equal to pi by 2, just test the continuity. So therefore f of pi by 2 is equal to f of pi by 2 is equal to mod of cos x, put x is equal to pi by 2, so mod of cos pi by 2, mod of cos pi by 2 means cos 90 is equal to 0, modulus of 0 is 0. So f of pi by 2 0. Now it is modulus function, so we have to take the left hand limit and right hand limit. So first, now left hand limit limit x tends to pi by 2 minus f of x is equal to limit x tends to pi by 2 minus function is same cos mod of cos x is equal to, just substitute for left hand limit we have to put x is equal to a minus h. Here a is equal to pi by 2, so put x is equal to pi by 2 minus h. Change tends to, if x tends to pi by 2, then h tends to 0. How it is 0? Just substitute this pi by 2 minus h here. Pi by 2 minus h tends to pi by 2, pi by 2, pi by 2 gets cancelled. Minus h tends to 0, that is h tends to 0. Therefore, left hand limit will become is equal to limit h tends to 0 mod of cos x is equal to pi by 2 minus h. Simplify this, limit h tends to 0 mod of cos 90 minus theta. 90 minus theta lies in first quadrant, and first quadrant all trigonometrical ratios are positive, so this is positive. In case of 90, change this cos into sine. So cos pi by 2 minus h will become sine h. Now substitute the value of h, mod of sine 0, and the value of sine 0 is 0, and modulus of 0 is 0 only. Now right hand limit x tends to pi by 2 plus f of x is equal to limit x tends to pi by 2 plus mod of cos x. For right hand limit we have to substitute x is equal to a plus h. Here a is equal to pi by 2, so put pi by 2 plus h. Change tends to, if x tends to pi by 2, then h tends to 0. How it is 0? Put this pi by 2 plus h here. pi by 2 plus h here, pi by 2 plus h tends to pi by 2, pi by 2 cancelled, that is h tends to 0. Therefore, right hand limit will become limit x tends to pi by 2 plus f of x is equal to limit h tends to 0 mod of cos pi by 2 plus h, which is equal to limit h tends to 0 mod of cos 90 plus theta. 90 plus theta lies in second quadrant. In second quadrant, sign is positive, it is cos. So minus sign. And in case of 90, we have to change cos to sine. So cos pi by 2 plus h will become minus sine h. You know, modulus sign consumes the negative sign. So it is limit h tends to 0 mod of sine h. Now we can substitute h is equal to 0. So mod of sine 0, and the value of sine 0 is 0 only. Mod of 0 is 0. So clearly right hand limit 0, left hand limit 0, and the value of function at pi by 2 is 0. So clearly left hand limit is equal to right hand limit is equal to f of pi by 2. Therefore, f is continuous at x is equal to pi by 2. So here we proved this function is continuous at x is equal to pi by 2. Hence proved. Question number 16. Find all the points of discontinuity of f defined by f of x is equal to modulus of x minus modulus of x plus 1. For this function, we have to find out all the points where this function is discontinuous. So f of x is equal to mod of x minus mod of x plus 1. You know, when the modulus function is given, then we can take the points inside the modulus sign. So for this, just substitute x is equal to 0 here. So one point will come x is equal to 0. When we put x is equal to 0 here, and x plus 1 is equal to 0, so x is equal to minus 1. So 2 points we will get, x is equal to 0 and x is equal to minus 1. First we will check the continuity at these 2 points, this function is continuous or not. So f of x is equal to mod of x minus mod of x plus 1. You know, when the modulus function is given, then we can get the point inside the modulus function. Just substitute the value inside the modulus function is equal to 0 and take the value of x. So here x only, so x is equal to 0 means 1 point, x is equal to 0. If we put this equal to 0, x plus 1 is equal to 0, that is x is equal to minus 1. So x is equal to 0 and minus 1. Test the continuity at this points, at these 2 points, x is equal to 0 and minus 1. So first at x is equal to 0. F of 0 is equal to mod of 0 minus mod of 0 plus 1, which implies f of 0 is equal to modulus of 0 0 minus modulus of 1, which implies f of 0 is equal to modulus of 1 1. So this is minus 1. Calculate limit directly, left hand limit and right hand limit one by one. First left hand limit limit x tends to 0 minus f of x is equal to limit x tends to 0 minus function is mod of x minus mod of x plus 1. For left hand limit, we have to put x is equal to a minus h. Here a is equal to 0. So put x is equal to 0 minus h. Change tends to, if x tends to 0, then h tends to 0. Therefore, left hand limit will become limit x tends to 0 minus f of x is equal to limit h tends to 0 mod of 0 minus h minus x is equal to 0 minus h and this plus 1. Simplify this, limit h tends to 0 mod of minus h minus mod of minus h plus 1. So which is equal to limit h tends to 0. This mod of minus h will become mod of h because this modulus sign consumes the minus sign, minus, we can write this 1 minus h, mod of 1 minus h. Now substitute h is equal to 0. Mod of 0 minus mod of 1 minus 0. Mod of 0 0 minus mod of 1 1. So this is minus 1. Now right hand limit and right hand limit. Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus the same function we have to take mod of x minus mod of x plus 1. Put x is equal to 0 plus h for right hand limit. Change tends to, if x tends to 0, then h tends to 0. Therefore, right hand limit will become limit x tends to 0 plus f of x is equal to limit h tends to 0 mod of x is equal to 0 plus h minus mod of 0 plus h plus 1, which is equal to limit h tends to 0 mod of h minus mod of h plus 1. Now we can substitute h is equal to 0, mod of 0 minus mod of 0 plus 1, mod of 0 0 minus mod of 1, mod of 1 1, this minus 1. So clearly right hand limit minus 1, left hand limit minus 1, the value of function at x is equal to 0 minus 1. Clearly left hand limit is equal to right hand limit is equal to f of 0. Therefore, f is continuous at x is equal to 0. Now, one more point, at one more point we have to check the continuity. This modulus sign inside the modulus sign x plus 1, when we put this x plus 1 is equal to 0, then x is equal to minus 1. So check the continuity at x is equal to minus 1 also. At x is equal to minus 1, f of minus 1 is equal to mod of x minus mod of x plus 1. Substitute x is equal to minus 1. So mod of minus 1 minus mod of minus 1 plus 1. Simplify this, minus 1 plus 1 cancelled, which is equal to mod of minus 1. Modulus sign consumes the minus sign. So this is modulus of 1 minus modulus of 0. Modulus of 1 1 minus modulus of 0 0. 1 minus 0 1 only. So f of minus 1 came 1. Now left hand limit and right hand limit one by one. First, left hand limit. Limit x tends to minus 1 minus f of x is equal to limit x tends to minus 1 minus function is mod of x minus mod of x plus 1. For left hand limit, we have to substitute x is equal to a minus h. Here a is equal to minus 1, so put x is equal to minus 1 minus h. Change tends to, if x tends to minus 1, then h tends to 0. How it is 0? Put this minus 1 minus h here, minus 1 minus h tends to minus 1 minus 1 minus 1 cancelled, minus h tends to 0, that is h tends to 0. Therefore, left hand limit will become limit x tends to minus 1 minus f of x is equal to limit h tends to 0 mod of x is equal to minus 1 minus h minus x is equal to minus 1 minus h plus 1. Simplify this. Limit h tends to 0. Take out minus modulus, mod of minus sign common, 1 plus h minus mod of here this minus 1, this minus 1 plus 1 cancelled. So mod of minus h, which is equal to limit h tends to 0. Modulus sign consumes the minus sign, so this is mod of 1 plus h minus, again modulus sign consuming minus sign, so this is modulus of h. Now substitute h is equal to 0. So 1 plus mod of 1 plus 0 minus 0. This is mod of 1, mod of 0 0, mod of 1 1. So left hand limit came 1, f of minus 1 1. Now calculate right hand limit. And right hand limit. Limit x tends to minus 1 plus f of x is equal to limit x tends to minus 1 plus modulus of x minus modulus of x plus 1. Substitute x is equal to minus 1 plus h. Put x is equal to minus 1 plus h. Change tends to, if x tends to minus 1, then h tends to 0. How it is 0? Just substitute minus 1 plus h here. Minus 1 plus h tends to minus 1 minus 1 minus 1 cancelled. That is h tends to 0. Therefore, right hand limit will become limit x tends to minus 1 plus f of x is equal to limit h tends to 0 mod of x is equal to minus 1 plus h minus mod of x is equal to minus 1 plus h plus 1. Simplify this. Limit h tends to 0 we can write this mod of h minus 1 minus this minus 1 plus 1 cancelled, so mod of h only. Now substitute h is equal to 0, so mod of 0 minus 1 minus mod of 0. This is mod of minus 1 minus mod of 0 0. This modular sign consumes negative sign, so mod of 1 only, and this mod of 1 is equal to 1. Notice right hand limit 1, left hand limit 1, and the value of function at x is equal to minus 1, 1. So clearly left hand limit is equal to right hand limit is equal to f of minus 1. So therefore f is continuous at x is equal to minus 1 also. So hence we can say this function is coming continuous at x is equal to 0 and minus 1. So we can say there is no point of discontinuity. Hence there is no point of discontinuity. There is no point of discontinuity. Question number 17. Determine if f of x is equal to x square into sine 1 upon x where x is not equal to 0 and f of x is equal to 0 where x is equal to 0 is a continuous function. This function is continuous, we have to determine this continuous or not. So here x is equal to 0, this function is defined at x is equal to 0, the value of function is 0. So therefore f of 0 is equal to 0, and for not equal to 0 means we can take greater than 0 and or less than 0. This function is defined for this. So calculate the left hand limit and right hand limit. Left hand limit for less than 0 and right hand limit for greater than 0. So first left hand limit limit x tends to 0 minus f of x is equal to limit x tends to 0 minus x square into sine 1 upon x. Now for left hand limit we have to substitute x is equal to a minus h, here a is equal to 0. So put x is equal to 0 minus h, change tends to if x tends to 0 then h tends to 0. Therefore left hand limit will become limit x tends to 0 minus f of x is equal to limit h tends to 0 x is equal to 0 minus h whole square into sine 1 upon 0 minus h. Simplify this, which is equal to limit h tends to 0, this is minus h square sine 1 upon minus h, which is equal to limit h tends to 0 minus h square whole square h square, and this is sine minus theta. We can say sine minus theta. So sine minus theta lies in fourth quadrant. Fourth quadrant cos is positive. This is sine. So minus sine 1 upon h. This minus sign we can write outside the limit. Limit h tends to 0, h square into sine 1 upon h. You know the value of sine h or sine theta lies between minus 1 and 1. So since sine theta belongs to minus 1 to 1, the value of sine theta is this only. For any angle, the value must lie between minus 1 and 1, minimum minus 1 and maximum plus 1. So here the value of this sine 1 upon h, we can take any finite value from here. So we can write like this, minus limit h tends to 0 h square into minus 1 comma 1, any finite value we can take. So from here, this minus, put the h is equal to 0 into any finite value, any finite value. When we multiply any finite value with 0, then total quantity will become 0. So left hand limit we have got 0. Similarly, the calculate the right hand limit, and right hand limit x tends to 0 plus f of x is equal to limit x tends to 0 plus same function x square into sine 1 upon x, x square into sine 1 upon x. For right hand limit, put x is equal to 0 plus h. Change tends to, if x tends to 0, then h tends to 0. Therefore, right hand limit will become limit x tends to 0 plus f of x is equal to limit h tends to 0, x square means 0 plus h whole square into sine 1 upon h is equal to 0 plus h. Simplify this. Limit h tends to 0. This is h square into sine 1 upon h. Again, we can take any finite value of this sine 1 upon h is equal to limit h tends to 0, h square into this minus 1 to 1. Any finite value we can take from here and put h is equal to 0 here, 0 square into any finite value. When we multiply 0 with any finite value, we will get 0. So clearly right hand limit 0, left hand limit 0, and the value of function at x is equal to 0 is 0. Clearly left hand limit is equal to right hand limit is equal to f of 0. Therefore, f is continuous at x is equal to 0. At x is equal to 0, this function is continuous. Now we can check the continuity for x is not equal to 0 or not equal to 0 means not exactly equal to 0, it may be greater than 0 or less than 0. So now let x is equal to a, which is not equal to 0. X is equal to a, any real number, but not equal to 0. Therefore, f of a is equal to same function x square into sine 1 upon x, x square into sine 1 upon x. Substitute x is equal to a where a is not equal to 0. So a square into sine 1 upon a, and calculate the limit x tends to a, f of x is equal to limit x tends to a, x square into sine 1 upon x. Here a is not equal to 0, so we can substitute directly x is equal to a square into sine 1 upon a. Clearly, limit x tends to a, f of x is equal to f of a where a is not equal to 0. Therefore, f is continuous at x is not equal to 0. Hence, we can say f is continuous for all real values of x. Hence, f is continuous at x belongs to all real values. Given the function f of x is equal to 1 upon x plus 2, find the points of discontinuity of the function f of x. So this function is defined f of x is equal to 1 upon x plus 2. So we have to find out where this function f of x is discontinuous, means point of discontinuity we have to find out. So function is given f of x is equal to 1 upon x plus 2. So at this point x plus 2, this f of x is not defined. So for discontinuity, this function is discontinued at x is equal to 2 first. And the function f of x, what is the value of this? Therefore f of x is equal to f of 1 upon x plus 2. 1 upon x plus 2. Now it is x. Substitute this x is equal to here. So which is equal to 1 upon x is equal to 1 upon x plus 2 plus 2 as it is. Simplify this further. 1 upon, take LCM, x plus 2 LCM, x plus 2 cancel, 1 plus 2 into x plus 2, 2x plus 2 2s are 4. It is double fraction. So shift this x plus 2 in numerator. So which is equal to x plus 2 into 5 plus 2x. This function is also not defined at 5 plus 2x. When this value is equal to 0, then function will be not defined. So therefore clearly f is not defined at x plus 2 is equal to 0 and 5 plus 2x is equal to 0. If these two values are equal to 0, then function will be not defined. So that is x should not be equal to minus 2 and x should not be equal to minus 5 upon 2. At this 2 point, this function will be discontinuous because this function is not defined at this 2 points. So therefore f is discontinuous at x is equal to minus 2 and at x is equal to minus 5 upon 2. At these 2 points, this function will be discontinuous. Last question for this exercise, question number 19. Find all points of discontinuity of the function f of t is equal to 1 upon t square plus t minus 2, where t is equal to 1 upon x minus 1. This function is defined in this way. So we have to find out the points of discontinuity. So f of t is equal to 1 upon t square plus t minus 2, where t is equal to 1 upon x minus 1 given. So first consider any third variable which is equal to this t, so that we can solve this in simple way or easy way. So let us consider t is equal to anything we can consider. I am considering this as equal to y. So therefore it will become f of y is equal to 1 upon y square plus y minus 2. This is the value of f of y. Now we can simplify this, and finally we will substitute y is equal to t and t is equal to 1 upon x minus 1. So this function f of y is not defined for y square plus y minus 2. If this value equal to 0, then this function will be not defined. So clearly f is not defined at y square plus y minus 2 is equal to 0. So this function is not defined for this value equal to 0. Now this is quadratic. So split the middle term in such a way that their product should be the product of first and last term, and their sum should be plus y. So product is negative, means one number may be positive and one may be negative, but sum is positive, means greater number should be positive and a smaller number should be negative. So consider two numbers, y square plus 2y minus y minus 2 is equal to 0. So 2y into minus y minus 2y square, on adding 2y minus y only. Take out y common, so y plus 2 minus 1 common, y plus 2 is equal to 0, which implies y plus 2 factor common, here y left, here minus 1 left, 0. So either y plus 2 is equal to 0 or y minus 1 is equal to 0. That is, y is equal to minus 2 or y is equal to 1. At these two values of y, this function is discontinuous. So that is, or therefore, f is discontinuous at y is equal to minus 2 and y is equal to 1. But we considered y is equal to t and the value of t is given, so we have to substitute that values. Now we considered y is equal to t or t is equal to y. So t is equal to y and the value of t is given 1 upon x minus 1. The value of t is x minus 1. Substitute this value is equal to y. So y we have to minus 2 and 1. So first, if y is equal to minus 2. So calculate the value of x from here. By cross multiplying, 1 is equal to minus 2x minus minus plus 2, which implies minus 2x will become plus 2x, 2 minus 1. So 2x is equal to my 1. So x is equal to 1 upon 2. One value of x is 1 upon 2 and 1 upon x minus 1 is equal to y is equal to, consider y is equal to 1 if y is equal to 1. So simplify this by cross multiplying, 1 is equal to x minus 1. 1 shift minus 1 this side, x. So x is equal to 2. So here we are getting this two values of x. X is equal to 1 upon 2 and x is equal to 2. So we can say at this 2 point this function is discontinuous. Hence f is discontinuous at x is equal to 1 upon 2 and x is equal to 2. At these 2 points the given function is discontinuous. So all the questions of this exercise 9.2 we have solved. One more exercise is remaining for this chapter. So from next class we will start that exercise. Till then, Okay, bye.